So next is the temperature and pressure dependence of viscosity. We have many data available for getting the viscosities of pure gases and liquids. And if sometimes these experimental data are lacking, we can make use of empirical correlations or empirical data to get the values of these viscosity of pure gases and liquids. So this empirical method of finding of the viscosity is called as corresponding states correlation. And here we are going to study about two charts to get the viscosity. So this is the first one. So here we are plotting reduced viscosity and reduced temperature, and the varying parameter is pressure. This is the reduced pressure. So actually what is reduced viscosity? It is actually the ratio of viscosity of gas at a given temperature and pressure divided by the viscosity at critical condition. That is, the equation will be mu r is equal to mu by mu c, and also reduced temperature equation is Tr is equal to T by Tc. This Tc is the critical temperature and this T is the given temperature. So the parameter varying here is pressure. So we can see that the curve for the pressure is decreasing in this direction, and it is saying that as the pressure approaches zero at a given temperature, the viscosity of a gas approaches a definite limit. This limit is called as the low density limit. This curve corresponds to low density limit, and preferably this low density limit is reached at a pressure about 1 atmospheric pressure. And the viscosity of a gas at low density increases with increasing temperature, whereas the viscosity of a liquid decreases with increasing temperature. And usually the values of this mu c, that is the viscosity at the critical condition, they are seldom available. So we can find out the value of mu c from two equations, or from two methods we can find out the value of mu c. So before going that, I will discuss one more chart with you, then we shall move on to the steps for finding out mu c. So this is the second chart available for finding out the viscosity. Here we are plotting reduced viscosity and reduced pressure, and here we are taking reduced temperatures. So this reduced viscosity is represented as mu hash. Its equation is mu by mu 0. That means this reduced viscosity is actually the ratio of viscosity at a given pressure and temperature divided by the viscosity at atmospheric pressure and same temperature. So here the values of Tr, the reduced temperature, is increasing in this direction. This is 1, this is 1.1, 1.2 and so on. Then, so I have mentioned earlier that there are two ways for getting the value of mu c. The first method is, if the value of viscosity is known at a given reduced pressure and temperature, then mu c can be calculated from the equation mu c is equal to mu by mu r. Or if only the critical pressure, volume, temperature data are available, then you have to make use of this equation. That is, first equation is mu c is equal to 61.6 into m into Tc raised to half Vc raised to minus 2 by 3. And if and another equation is mu c is equal to 7.70 m raised to half pc raised to 2 by 3 tc raised to minus 1 by 6. This we get the values of mu c in micropoise, pressure, pc in atmosphere, tc in Kelvin, and vc in cc per gram mole. So based on the data available, you can choose any one of these equations for getting the value of mu c.